Okay, so the first thing I'm going to do is draw the pentagon. It's upside down, so we draw the top.
Sorry, but all the first year planning to go to Athlone tomorrow for the indoor athletics. Please be excused from class now because the weight must be order in G6 will give Agnes a chance to go away for the month. Thank you.
So it's a pentagon, so it's 360 divided by 5 sides, so it's 72 degrees. All edges are the same size. You can measure them around with your compass. Okay, and it's resting on the XY line. And to find the apex, so it's in line there, and then you can bisect the line or the angle, whatever suits you, and where it intersects to find the center point. So just bisect this line here. And that'll be the center point. So the question tells you that's point 1, 2, 3. So we go with 4, 5, and 6. Join them all back to the apex. Okay, all the base is resting on the vertical plane, so they're going to sit on the XY line because it represents the vertical plane in plan. Okay, in the question it tells you then the hinge point is along edge 1 and 2, so it's a hinge line. Okay, so we always will look along the hinge line to set our drawing up. So we're needing an auxiliary plan so we can see the vertical plane as an edge view. Okay, so plan, an auxiliary projection from elevation is an auxiliary plan. Okay, all our points then are going to move parallel to our line of sight. And we know all our baselines are sitting on the XY line, so they're going to be sitting on the X1, Y1 in this view. Slightly off. Just make sure they're parallel. Okay, so we have 5, 6, 4, 1 and 2, and then 3 is now 50 mil. Okay, so our hinge point is projected. When we look along a true length, it will be projected as a point view in plan. And in the question it's telling us edge 1, 2 and 3 has to be rotated and lying flat against the vertical plane. So using our compass, taking 1, 2 as our point of rotation, we get that and we can start lining it flat. Okay, so just rotating it around till it hits the vertical plane, which is represented as the XY line in plan. That's 1, 2 and 3. Next thing we do then is we can find point 1 and point 5. So they're the same. 3 is 1 and 5 the same distance away from 3 in every view. There, so we can just take it there, and then 1 to 2 the same distance away. With 2 lines intersect each other, we'll give you point 1 and point 5. Okay. So 1 to 6 and 4 are the same distance away, and they're on the base, but you can double check it. 1 to 5, 6 and 4, 1 to 5, 6 and 4, and they intersect each other in the exact same place. So that's 6 and that's 4. And we can bring it back then into our view. Okay. So they asked us to get edge 1, 2 and 3. Take it and lie it flat against the vertical plane. There's the edge 1, 2 and 3. There. And we've done that. We've taken our auxiliary view, seen it in its original position, and rotated it so it is lying flat against the vertical plane. Okay. I'll just heavy that in black so you can see it. Okay, so once we've that done, all our points are going to move parallel back to our line of sight. We're in plan, so we have to go straight back into elevation. So 3 is along that line, so 1 and 5 is along that line, and 6 and 4 is along that line. All points will travel through the hinge line, and that's the hinge line there. Will travel perpendicular through it. So 1 and 2 are stuck on the ground. We know 3 will travel perpendicular through it, out to 3, so that's going to be point 3. And 6 will travel perpendicular. So where 6 meets 6, we'll give you point 6. And where 4 meets 4, we'll give you point 4. So up and across, that's point 4. Next thing now we need 1 and 5. There's 5. Is that not 1 and 5? Just 5, we have 1 already. So 5 is going to be on that point there. Okay, so this, when it's tilted, we're looking underneath the pentagonal base pyramid so we can see the base of it. So 1 goes to 6, 6 to 5, 5 to 4, 4 to 2, and then all our edges go, all our base points go back to our apex. So we can heavy that in black. So 2 goes to 4, 4 goes to 5, 5 goes to 6, and 6 goes to 1. And 4 goes back to the apex, 5 goes back to the apex, 6 goes back to the apex. 1 goes back to the apex, but it's hidden detail at the back, so we can put in as a dashed line. And 2 goes back to the apex. It's also hidden detail. Okay, so we have got our plan elevation, found an auxiliary view, rotated it so we could find it to satisfy the question, edge 1, 2 and 3, or face 1, 2 and 3, line flat against the vertical plane, brought it up into elevation, and we now have our edge, our surface 1, 2 and 3 rotated about 1 and 2, and edge 1, 2 and 3 then is touching or lying flat against the vertical plane. Okay, so once we've that done, we need to finish our plan. So what do we know about all our points in planned elevation? They're directly above or below each other vertically. So 3 has to be on that line, and we know 3 is touching the vertical plane, which is represented as the XY line in plan. So there's point 3. 1 and 2 stays in the same place. 5 has to be along that line somewhere. You know 5 is on that line somewhere. We know 6 is on that line somewhere. And we know 1 and 2 stay in the same position. Okay, and we know 4 then, the only one we've left, has to be on that line somewhere. Okay, so we take our heights, or not our heights, be more distances from our vertical plane. We know distance 1 is the distance from the vertical plane to 6 and 4, and distance 2 is going to be the distance from the vertical plane to point 1 and 2. So use it in our compass, take distance 1 for 6 and for 4. Okay. Now we have point 6, point 4, 1 is there, and 2 is there, and 3 is there. So we need to take sorry, there's 3 in there. So we just need to find point 5. It's not 1. 1 is stuck over here. So point 5. So we drop it down, and we know point 5 is on the line there somewhere. So that's going to be point 5. Okay, so 5 will go to 6. 6 will go to 1, you can see here. 5 to 6, 6 to 1, 1 to 2, 2 to 4, 4 to 5. It's the exact same in plan. Okay, 1, 2 and 3 are going to be a straight line now because lying flat against the vertical plane. We have edge 5 to 3 to the apex, and 4 to 3 which is the apex, and 6 to the apex, but it's going to be hidden detail at the back. Okay, and then we're going to have our surface 1, 2 and 3 lying flat against the vertical plane, and that will be the question, the solution to that question finished. Page 62, question 5.